Okay, very good morning children. We will be discussing about periodic properties in terms of competitive exam. Recently, last 3-4 years back, how the questions came. For that, what are the shortcut tips required that we will be seeing. Suppose for finding the boiling points. So in some exams they are giving like this. Find out the boiling point. Means what we will have to do. Let us consider one question from our periodic properties only, okay, which is written like this. Okay, what is that means? The boiling point of chromium and radon are minus 152 degrees Celsius and minus 62 degrees Celsius respectively. Find the approximate boiling point of xenon. This is the case which we had. See, generally, sir, how we will find the boiling points? For this, what we can use is we have Dobereiner-Trites formula. What is a trite? Trite is a group of 3 elements. Is it or not? So we will apply the trite rule for this to solve. Generally, what are the trite elements for this? Krypton, xenon, and radon. Now, there what we use, the average of the first and third will represent the second one. Here also the same we will find. Okay, boiling point of xenon. Boiling point of xenon is equal to boiling point of krypton plus boiling point of radon by 2. Then what is the boiling point of krypton? We have minus 152 degrees Celsius plus what is the boiling? Minus 62 degrees Celsius by 2. So both are minuses means we have to add them. So 152, 62, 2 to 4, 11, 214, minus 214 by 2. So how much it is coming? 2 ones to 107. So 107 degrees Celsius. So how we can write now the boiling point of xenon is minus 107 degrees Celsius. We can make like this. Is it or not? Any doubts you can ask. So how to find the boiling point? This is one concept for finding the boiling points. The next one what we have is regarding the boiling points, that is the situation. Suppose if you want to find the bond length, okay, if you want to find bond length, then how this is done? How to find the bond length? Generally, bond length means what? Bond length is nothing but it is the distance between the two nucleuses. Is it or not? It is the distance between the nuclei of two atoms. Bond length is nothing but distance between. It is the distance between the nuclei of two atoms. So that is the bond length. So how we can find the bond length? For that we will give an example. Okay, let us consider if the bond length of in CCl bond distance of CCl4 is 1.76 angstroms. Okay, and if atomic radius of carbon is 0.77 angstroms, what is the atomic radius of chlorine? So this is the example. See what I am saying, the bond length is nothing but distance between the nuclei of two atoms. Here what they have said is in CCl4 the distance between C and Cl4 is 1.76 angstroms. Okay, and the atomic radius of carbon is this much. What is the atomic radius of chlorine? See, generally distance between the nucleus atoms is nothing but the radius between the atoms only. No, it is considered as the radius only. So what I can write, bond length of CCl is equal to radius of carbon plus radius of chlorine, that is Rc plus RCl. This is nothing but the bond length of carbon and Cl. Now what is the bond length given? Actually here it is 1.76 equal to, what is the radius of the carbon? 0.77, and he asked you to find the radius of chlorine. So radius of chlorine is equal to 0.77 minus 1.76. Correct only? Wrong it is. By RCl you have to keep in that side only. So first you have to avoid that confusion. For PCB students I am saying this, 1.77 minus 0.77 equal to RCl you can write. Now RCl equal to 1.76 minus 0.77. So now RCl equal to how much? 1.76 minus 0.77. So it is coming around 0.99 angstrom. So this is the radius of chlorine atom. What is the radius of the chlorine atom? Means this. So bond length. If bond length is given and asked you to calculate the radius also, you can do like this. So the answer is what? The radius of atomic radius of chlorine is 0.99. Now for another competitive examination point of view, what is the, generally we have studied electronegativity, electron affinity and ionization potential. See, we have studied electronegativity, okay, ionization potential and electron affinity also. Okay. So let us consider the symbol as En for electronegativity and ionization potential Ib and electron affinity as Ea. These are the symbolic representations for our class. Now what is the relation between En, Ib and Ea? Now we are going to have the discussion between relation between electronegativity, ionization potential and electron affinity. Now electronegativity. So generally we have with the notation, electronegativity is nothing but average of ionization potential and electron affinity. That is the relation. Okay. Electronegativity is equal to ionization potential plus electron affinity by 2. is the relation between electronegativity, ionization potential and electron affinity. Okay. And one more thing we have, one small problem we will have a discussion. How much energy in joules must be needed to convert all the atoms of sodium to sodium ions present in 2.3 milligrams of sodium vapors. See, the question is very clear. How much energy in joules must be needed to convert all the atoms of sodium to sodium ions? See, conversion of sodium to sodium ions means you should know the ionization energy. So here in the question they will give ionization energy of sodium is 495 kilojoule per mole. Okay, 495 kilojoule per mole it is given. Now what he is asking you how much of amount for energy is required to ionize these many grams. See, it is measured in moles, but this is in grams. So first you have to calculate number of moles first of all. Is it or not? So number of moles present is equal to weight by molecular weight. Is it or not? Weight is 2.3 milligrams. So it is nothing but 2.3 into 10 power minus 3 grams by its molecular weight. What is the molecular weight of sodium? How much you are getting it? 23. Is it or not? So it will come how much? 23 into 10 power minus 4 by 23. So it is nothing but 10 power minus 4 moles. Okay, 10 power minus 4 moles. See, what is the ionization energy here? For 1 kilojoule, for 1 mole it is 495. See, for 1 mole it is how much? 495 kilojoules. So for 10 power minus 4 mole, okay, how much it will be? So it will be 495 into 10 power minus 4 kilojoules of energy. Is it or not? Okay, so how much of energy is required per mole? Sorry, per mole it is required. That much of kilojoules of energy is required. Okay, how much energy in joules must be needed to convert all the atoms of sodium ion to 2.3 milligrams? Means this much of energy is required. 495 into 10 power minus 4 kilojoules per mole of energy is required to convert 2.3 milligrams. Okay, if you have any doubt you can call me or do WhatsApp. See, for 1 mole it is 495 kilojoules. So we got how many moles? 10 power minus 4 moles. So 10 power minus 4 moles will have this much, 495 into 10 power minus 4 kilojoule per mole. See, this topic is first chapter, we can consider it under the atomic structure. We can also consider it under the periodic table. Linked questions these are. So that's why I have written revision. And regarding the radius for the same element, okay, for the same element, you can calculate the covalent radius. Is it or not? Covalent radius, van der Waals radius, okay. For the same elements, you can calculate the van der Waals radius and also crystal radius. Then how the values will be, okay, for the same element, how the values will be. So how the values will be means how they will be. So first, the highest radius is van der Waals radius. In any atom, for the same elements, if the distance for the same element, van der Waals radius is the highest one. It is greater than the crystal radius. And the crystal radius is greater than covalent radius. Okay. So for competitive exam side, this is important. Suppose if they give you for an element which has the highest atom, which radius will be the highest. Always van der Waals radius will be the highest and the least will be the covalent radius. And another point what I had to discuss is the ionization potential. The ionization potential of ion X minus is numerically equal to the electron affinity of X atom. Okay. See, the ionization potential of an ion of that particular element is numerically equal to the electron affinity of that X atom. How means you can see the explanation. See, what is that? What is the electron affinity? The amount of energy released when an electron is added to a neutral gaseous atom. Is it or not? So X plus electron minus is giving how much? When electron is lost, what we call it as X minus plus electron affinity, that is EA. Some energy it will give. Now the same X sign, okay, X minus ion, that is the anion. When we add some energy, then it forms what? An atom, and electron is gained. See, what is happening when you add these two? You will be getting electron cancelled, ionization energy and electron affinity are both absent, X cancelled, X gives X only again. So this is about the ionization potential of X minus ion is numerically equal to the electron affinity values. Okay, experimentally it was found. Okay. Still, if you have any doubts, you can ask me. So you note down these as a points. For the same element, van der Waals radius will be greater than crystal radius, and crystal radius will be greater than covalent radius. And the ionization potential of an anion is numerically equal to the electron affinity of that particular atom. For solving the problems for both in NEET and JEE, these are important. Okay, we will be having the discussion regarding the periodic properties. Okay, under that periodic properties. Okay, under that periodic properties, first regarding some point regarding the electronegativity. So generally electronegativity, suppose if it is sp3, sp2 and sp are given, then how the electronegativity will be? Means electronegativity character increases with the percentage of increase of S character. So electronegativity increases with increase in percentage of S character. Okay, it increases with increase in percentage of S character. Okay, if the S character is more, then there will be the more electronegativity. Suppose in sp3, S character is 25% and P character is 75%, whereas in sp2 50-50. In sp, okay, in sp it is 50-50. In sp2, here again it is 3 parts and it is 1 part. 2 parts and 1 part. Here equal. So as the S character increases, the electronegativity also increases. And regarding the cation and anion, okay, how the enthalpy will be there, that also one more discussion we will have. As the nuclear charge increases, as the nuclear charge increases, the force of attraction between the nucleus and the incoming electron increases, and hence the electron gain enthalpy becomes more negative. Means suppose if cation and anion are there, then which will be that? Means cation is always less than the anion in case of the electronegative enthalpies. So that is the thing, electron gain enthalpy becomes more negative in case of cation and anion. As the nuclear charge increases, the force of attraction between the nucleus and the incoming electron increases, and hence the electron gain enthalpy, that is nothing but electron affinity, becomes more negative. Suppose if both are having the same charges or different charges, then what about the things? Cation. So the cation with least charge is less than cation with highest charge, and is less than with anion with highest charge. order of the cations with respect to their electron affinities. Okay, how the electron affinities will be means accordingly like this. Electron affinities. Suppose if you take, let us consider carbon. Carbon charge is Ca2 plus, aluminium is Al3 plus, and oxygen O2 minus, and F is fluorine is F minus. So now when it comes to the charges or electron affinity, this is the order. Ca2 plus cation with least charge is less than with the anion. Okay. Next, anion with the highest charge is less than with the anion with the least charge. So these are the things you have to follow. Ca2 plus is less than Al3 plus less than O2 minus less than F minus. Electronegativity increases with the percentage of S character. That is the important. Now we will be having some points regarding the coinage metals again regarding the electron affinity point. So it is clearly mentioned electron affinity of second period non-metals is less than that of third period non-metals. Okay. Electron affinity of second period non-metal is less than that of third period non-metal. Okay, so that is the thing, and you already know that silver, gold and copper, these are called as coinage metals. In social studies you might have studied these are the coinage metals, and already we had a discussion that fluorine is the highest electronegative element. Fluorine is the highest electronegative element. So it is chemically most active element. Is it or not? It is the chemically most active non-metal. Okay, fluorine is the highest electronegative, and so it is chemically the most active non-metal. And when it comes to isoelectronic, what is an isoelectronic? Iso means same, electronic means electronic configuration. There are some points in the previous exams what they asked, that points I am going to stress now. For isoelectronic, species, ionic gravity decreases as the charge on ion decreases. On moving down in a group, ionic gravity increases. Okay. For isoelectronic species, what happens? The ionic gravity decreases as the charge on ion decreases. See, as the charge on ion decreases, the ionic radius also decreases. And further, what happens? On moving down in a group, ionic radius increases. If you take group-wise elements, what happens? The ionic radius will increases. But in case of isoelectronic species, what will happen? It decreases as the charge of the ion decreases. That is the major point. Okay. And next, radii of ions, radii of anions carrying same charge, carrying same charge decreases from left to right, decreases from left to right in a period and increases down the group. Okay, so the radius of anion carrying the same charge will decreases from left to right in a period. In a period, what will happen? Suppose if you take a chlorine, fluorine, these are the anions only, but the radius of the same charge, okay, same charges. Then what will happen? It decreases from left to right in a period and increases down the group. That is important. Okay. So these are the some points. You can make a note of all these points. Okay. Next, some more points. What are the some other points we have? Is van der Waals radii. Okay. Okay. Van der Waals radii. It decreases as we move from left to right in a period. In a period, as we move from left to right, it decreases. Okay, it is due to increase in the nuclear charge. It is due to increasing of nuclear charge. It is due to the increase of the nuclear charge. This is going to happen. So these are all the points which from the various previous years question paper, some points we are stressing. Okay. So there are a few points which we will be discussing. Generally, as we move from top to bottom in a group, the metallic character increases. As we move from top to bottom in a group, the metallic character increases, and we move from left to right in a period, the metallic character decreases. And already we have seen, when compared to the parent atom, the size of the cation, okay, the size of the cation will be less than that of that neutral atom. Is it or not? And the size of the negative ion, that is the size of the anion, will be greater than the neutral atom. Okay, so size of the negative ion is greater than the neutral atom, and size of the anion, that is positive ion, that is the cation, is less than the neutral atom. Okay, size of the anion is always greater than the parent atom. In a simple sentence, size of the anion is greater than the parent neutral atom, and size of the cation is always less than the parent neutral atom. Okay. Next, when you have positively charged particles, the more positively charged particle will acquire the higher energy to remove the electron than from a more negatively charged ion. Okay, more positively charged ion will require high energy Why it requires high energy means already it has lost one electron. No. Again for removal it requires more higher energy than compared to that of the anion. In anion what we are having, it is having a addition of electrons only. So that is the difference. Next, generally in competitive exams they are asking which of the following is amphoteric oxide. Till now these three are only being asked: SnO2, ZnO and Al2O3. Those are the amphoteric oxides. Okay. So generally metallic oxides when reacted with metallic oxides, they will form what? Metallic oxides will form bases, and non-metallic oxides will form acids. That is the major case. Non-metallic oxides will form the acids and the metallic oxides will form the bases. So basicity of the oxides decreases in a period. Basicity means what? The number of replaceable H plus ions is called as the basicity. Basicity is nothing but replaceable H plus ions. So the basicity of the oxides, as we move from left to right, it decreases, and as we move from top to bottom in a group, it increases. So these are the things. And next, electronegativity. When it comes to the electronegativity, higher the positive charge, the larger will be the electronegativity. Higher the positive charge, the larger will be the electronegativity. And higher the negative charge, the lesser will be the electronegativity. In case of cations, if more cations charged, if the charge is more, means more amount of electronegativity is required. In case of anions, lesser the charge, lesser the electronegativity. Sorry, higher the negative charge, lesser the negativity. And for isoelectronic species, anion size of the anion increases as the negative charge increases. Okay, if the negative charge is increasing, Cl minus and O2 minus. Okay, for isoelectronics, size of the anion increases as the negative charge increases. Okay, and as we move down in a group, the electron affinity, electron gain enthalpy is nothing but electron affinity. It becomes less negative because the size of the atom increases. When the size of the atom increases, what will happen? The distance of the electron from the nucleus also increases. So these are all the revision points of periodic properties. Okay. So once I am repeating, see, metallic character decreases in a period and increases in a group. The size of the negative ion, that is anion size, is always greater than the neutral parent atom, and cation size is always less than the neutral parent atom. More positively charged ion will require high energy to remove an electron than that of the more negative charged ion. Higher the positive charge, the greater is the electronegativity. Okay, higher the positive charge means more cation. If it is having, suppose if you take Na plus and Mg2 plus, which has highest electronegativity, means Mg2 plus has the highest electronegativity. Why? It is having higher positive charge. Okay, and when it comes to the negative ions, O2 minus and Cl minus, so which has the higher electronegativity, means Cl minus has the higher electronegativity. Okay, O2 minus has the lesser electronegativity. Generally metallic oxides form metallic oxides will form basic in nature, and non-metallic oxides are acidic in nature. Okay, so Al2O3 is amphoteric oxide, ZnO is amphoteric oxide, and SnO2 is amphoteric oxide. Why? Means these are all metals, but they form amphoteric oxides. And what is basicity? The replaceable number of hydrogen H plus ions. Okay, so the basicity of oxides decreases in a period and increases in a group. For isoelectronic species, the size of the anion increases as negative charge increases. As we go down in a group, electron gain enthalpy becomes less negative because the size of the atom increases and the distance of added electron from the nucleus also increases. So these are the cases.